You were right at the 66,000 with the sun going, or how fast we go around the sun. That's 66,600.
Yeah. Like 2.1 light years or some shit.
It's 1.3 million.
1.3. See, I said like 2.
Yeah, but that's 700. Yeah, 700,000 off, bro. Come on, man.
I know you like to say like NASA means to deceive and shit like that.
Yeah.
Man, that shit don't mean to deceive.
Oh, really? No. What's it mean? What's the Hebrew origin of the word mean?
But the word you're talking about is nashah.
Yeah, well, I know it's in English transliteration. You add the H for pronunciation. What's the Hebrew root word mean?
To lift up.
To lift up and to deceive are the same root word. So you want to bet money on it? No, you're right. You're right that it's nashah. That in English transliteration it has an H. That's because of pronunciation purposes. And in Hebrew it has the same 4 characters. It just has a different character above the other characters. Yeah.
First of all, it's not even a word, bro. It's an acronym.
Okay, well that's a different argument.
Before that, it was NECA.
Okay, so NASA does mean to lift up and to deceive. That's the Hebrew root words.
And you gotta see if anybody who speaks Hebrew, they're gonna disagree with that.
Yeah, man. Hey, so since you're clearly the guy that watches my videos but thinks the Earth's a globe, is the physical Earth curvature, like, is the horizon, is it physical?
It's apparent, but anything you see is apparent.
Right.
You got atmosphere.
So we never actually see that actual physical curve then?
You can see the effects of curvature, or you can see the actual curvature. You go high enough.
So what height do we not see apparent horizon where we see actual curvature?
Shit, you can see it from a plane.
So in a plane, it's not the horizon's not apparent anymore.
I mean, you're cutting through a lot of that atmosphere around 35,000 feet. So
you do cut down on atmosphere when you increase
curvature. Greater Sapien did a video on that.
Okay.
Where he put the theodolite.
Yeah.
And he compared it at ground level.
Yeah. So when we go up in the plane, are we seeing the actual curvature, or is it just appearance?
You're seeing the actual curvature.
Really?
Yeah.
That's crazy. Based on the geometry of the Earth, you wouldn't see the curvature of the Earth anywhere close to 35,000 feet. You have to be way higher than that. Not even 252 miles according to the world's biggest observatory.
Nah, you can't quote mine, Neil deGrasse on that.
No, Neil deGrasse Tyson is not talking about the world's biggest planetarium. He said you couldn't see it from the ISS, 252 miles. Neil deGrasse said you couldn't see it from 63 miles or 128,000 feet. Geometry says you couldn't see it from past the ISS. Just saying that you can see it because Google says it. I know hundreds of pilots that have never seen a curvature of the Earth in their life. I guess thousands of flight hours doesn't count though. We just watch one guy on YouTube say you can.
You're talking about quantum eraser, we were talking about 1.225 and that shit.
No, that's actually just geometry. That's not quantum eraser. That's geometry.
Yeah, but that didn't factor in refraction.
Okay, so you're going to add refraction to it?
Well, I mean, when you say you can't see the horizon from a certain amount of distance, that it should be at 1.225.
Times the square root of the observer side feet, yeah.
And you say, oh, we see too far.
That's right. So you're not accounting for refraction.
Yeah, you're not accounting for
So how much does refraction change it?
Shit, just depends, bro. On fucking Snell's law, Fermat principle, they got...
Snell's law is actually not applicable to the atmosphere.
Fermat's principle.
It's a differential of Snell's law. And if you assume terrestrial refraction, that's what your side does. The subject matter expert, Andrew Thomas Young, the guy who made the math up for you that saved your religion. If you apply terrestrial refraction to the curvature, it would extend 1.22 to 1.32. So how does that help you with 10 miles?
No, that ain't right. That ain't right.
You know, maybe $1,000 is right. It's right, bro. It's Andrew Thomas Young's terrestrial refraction, standard refraction would extend it to 1.32.
Hey, one more minute.
Oh, I'm sorry that they lied about the Earth, guys. Don't make it real.
Hey, bro, you know the Earth is a globe, bro. You do the
Do I?
Do I?
Then why not see?
You're good at what you do.
Why not see mountains 300 miles away? I gave up 6 figures to do this, so like.
Hey, I don't doubt it, bro. You got a good number.
I don't make 6 figures now, though. So like, why did I give up 6 figures to do this?
Shit, you make good money doing this shit.
You think I make 6 figures doing this?
Nah, but you prefer to do your own thing.
But I've spent thousands on this store. I haven't spent my own money.
Shit, you do this because
that don't make sense.
You want to feel special, bro.
Okay.
That's what flat earthers do. They want
to. All right.
Why is that water in your he gets level.
That's gravity.
So okay. So if gravity keeps
See if you can debate my girl, bro.
if gravity keeps water on the ball,
Dude,
right?
that's 3 times in a row that Glover's come out.
Why is evaporation defying gravity? There you have water vapor going up.
You're not even gonna get the money.
It's minute molecules.
But why is it going up?
Matthew Dahman, Dolly Bear.
That's my buddy.
Okay.
Get more dense air.
But I thought there was a downward force pulling things to the center of mass.
Yeah, the more mass
This does not pick you up.
So you're saying gravity exists. There's a downward force pulling things to the center of mass, but yeah, we see things going up. So is a helium balloon going up and down at the same time, according to you?
Yeah, it's still being affected by gravity, but it's being pushed up by the air.
So, okay. These are what Globers have to say because they realize that they're caught in a conundrum because they're saying that things fall to the ground because of gravity, yet we can see time and time again things rising like a helium balloon. But they have to say, that is a flat earth argument that everything that you're observing is just simply relative density. A good example of relative density is ice cubes. Ice cubes fall in room air, but they float in your cocktail because that's relative density.
Downward force, though. Buoyancy only it requires an opposing force. So what's the opposing force on the flat earth?
What if it's electrostatics? How do you know it's gravity? They never actually were able to isolate. How do you isolate gravity and then put that through the scientific method?
Well, can you show me an equation for electrostatics that we can do with gravity, like the way we found Neptune?
Everything is intrinsically electrostatic. Even Harvard admits this. So if you're going to say, because obviously we can see that things are going down, but actually establishing the cause would require things to go through the scientific method, which requires isolating the independent variable of gravity. And the only thing that they have close to a scientific experiment is observing a solar eclipse. But for a scientific experiment, you actually have to manipulate the variable. Observation is not manipulation. And correlation is not causation. So you have to isolate it to know that it's the cause. So you can't use gravity as an established cause.
There's tons of evidence for gravity, like Cavendish, the Schehelian experiments.
Cavendish has nothing to do. Cavendish had to do with the density of the Earth.
Mass attracts mass.
That was superseded by Einstein. So now actually, so Globers are so out of date with their own pseudoscience. It's not mass attracting mass. It's the bend. Einstein followed up with this. It's the bending and warping of space-time.
It was superseded. That's what you said?
Yes, it was superseded. I have academic sources for you if you would like.
That's wrong. It was just refined. It wasn't superseded.
Okay. Let me get my phone out. No, it is not mass attracting mass anymore. You would have failed Astronomy 101 in college. Because also now gravity is not a force. It's the bending and warping of space-time, according to the globe model. No. All right, let's get this. Okay, so
Knowledge is good, right?
this is from
It
libertext.org.
can be written either way.
Newton's two crowning achievements, the laws of motion and the laws of gravitation that held reign supreme since published in the Principia in 1687 were toppled from the throne by Einstein.
Not much, bro.
Thank you, bro. Thank you.
You trust me?
These are academic sources.
So,
No,
anything?
I'm not saying I trust them, but if we're going to debate people about the globe, they have to actually know the modern day explanation of gravity.
So you trust that? I can find anything
I
online.
don't trust this, but if
So
you're
why
going
you
to
pulling it
argue for the globe.
So are you disagreeing with the top people on your side?
I'm just here for fun.
That's super weird.
Yeah, I'm just here for fun.
Alright, watch this. You can't debate me on gravity. We both know that.
So gravity,
So what's the theory of relativity? Can you define it?
EC squared. No, sorry.
It's first of all, it's E equals MC squared.
Oh yeah, that's right. You're good.
Right. But
So you agree that?
manifestation of space-time curvature.
So you agree mass attracting mass is no longer the theory of
No, it
gravity?
still works.
No, it
Mass
doesn't.
attracting mass still works.
Really? How so? How's it work?
The only difference is action at a distance.
Okay, so there's a fundamental difference, right? So if matter has an intrinsic property of gravity, that's mass attracting mass. That's not the case anymore. Gravity is now the effect of the bending and warping of space and time around the matter.
Right, but that's on
different.
extreme levels. You know,
No, that's just
here,
different.
Locally, for everyday purposes, Newton works just fine.
Really? So can you prove mass attracting mass?
Sure, Cavendish.
Cavendish proves it?
Helium experiment.
How's Cavendish prove it?
There's even places where the mountains, they'll mess with the tides and shit. You know what I mean?
Yeah, like when you mapped out gravity.
What do you get if you do it?
What?
What do you get if you do it?
Do what?
The pull-up bar. He's talking
You
about
win $100. You got a page 20 to play. You win $100 if you make.
I thought it was like
Yeah, gravity, like you said.
If you map out gravity, assuming it's real, it's off all over the world. And Canada has a huge discrepancy. So there's no evidence for gravity. So that's just a fact.
There's tons of evidence.
So what's the evidence?
Why does a helium balloon go
Go up?
forward when you accelerate?
Why does it go forward when you accelerate?
It means let it go up. Wants to go up.
Yeah, why is a human balloon go up?
No,
Yeah.
in a vehicle, I mean. In a vehicle, you put it
It's in a controlled closed system when you added a force of
You
acceleration.
already had a
to-
force, though.
Yeah, but that doesn't do
Wait,
with gravity.
move out of the camera. Move out of the
That's-
camera.
that's
Move out of the
good.
camera.
Good
Thank
Move
you.
out of the camera.
Thank you. Thank you. Thank you.
This is my live stream there.
Oh, thank you.
Scientific
Thank you.
principle.
I don't know if you're new to this.
I'm new. I'm very new. Thank you.
Feel free to not tell me how to run my life.
I am, thank you.
What's up? Everyone thinks you're lame though. So why are you trying to run it?
Because I'm lame AF.
I know. Anyway,
So why are you covering them? If you're
because I'm trying to
right.
talk to this
Oh,
guy,
I'm sorry. I'm sorry.
and you've proven yourself to be completely unknowledgeable.
I am very unknowledgeable. Yes.
We know.
Yes.
Okay, so here's a simple fact, right? The reason mass attracting mass was updated was that it didn't work. So when you went around talking to Globers nowadays, they'll say, well, it's practically the same and it's just a little different. It didn't replace it because they're just told what to say from globe earthers on the internet or whatever. But the truth is, I read the theory of relativity. I happen to know the problem. Mass attracting mass doesn't work outside of the local scale. It doesn't work. Okay, so it doesn't work.
Then you got to use Einstein.
Yeah, so that means, okay, well, if gravity is real, it's the same everywhere. It's the same everywhere. That's why Newtonian principles were dismissed over 100 years ago, because it doesn't work. There's no way around it. There's a fundamental difference. Mass attracting mass, matter has an intrinsic property of gravity, theory of relativity, proposed by Einstein in 1915, built upon 1905 special relativity, attributing a constant speed to light, which is saying that gravity is the effect of the bending and warping of space-time. The displacement of mass results in a gravity well. It isn't the actual matter that has an intrinsic property of gravity. It's actually the area around it made up of the fabric of space-time, bending and warping relative to the matter that makes gravity happen. Those are fundamentally, no, it doesn't make mass attracting mass. Those are different things.
It's an effect.
They're different things.
Of mass.
No. Okay. Do you understand the difference? In mass attracting mass, the cause is mass attracting mass. In theory of relativity, the cause is the bending and warping of space-time. Those are two different things. And I can get real specific, and I happen to know you can't answer this, bro. Okay, so
I ain't looking into it like you.
Yeah, but that's why you're a globe earther.
You're good at living in that gray area, bro.
No, I'm speaking about science. Okay, so everything that exists is intrinsically electrostatic. Do you know what electrostatic is?
Show me the equation of how we found Neptune with electrostatic.
How we find Neptune without it?
We found it with
Telescopes.
We found it with Einstein.
Really?
Yeah.
How'd that happen? We found Neptune.
We noticed the
That's crazy.
perturbation.
So how come Neptune was known about long before Einstein then?
It wasn't.
Yeah, it was.
No.
There are star charts and planet